going to need some cornstarch, water, a container to mix in. This is the style container that I have for today. And you can get a spoon or something to mix, or you can just mix with your hands. If you want to have some measuring cups out, you can use measuring cups. It'll be roughly a 2-to-1 ratio of cornstarch to water, or you can just eyeball it, and we're going to slowly add the water in. I'm Talena, Dr. Talena. I work as a researcher at McMaster University in the Sheardown lab. And so we're an engineering lab at McMaster, and we focus on the eye. So we're trying to find better ways to treat the eye when there's issues with the eyes. But my background is in chemistry, so I have my bachelor's and my doctorate in chemistry. So I'm not the type of doctor that you would go to when you're sick, but I am a doctor that knows a lot about chemistry. So the next experiment is a cornstarch and water experiment. You can get your container out and your cornstarch and your water. And what we want to do is we want to have about 2 parts cornstarch to 1 part water. And so you can use a measuring cup again, or you can just eyeball it. We're not going to add the water right away. We're going to slowly add the water. So it's better to add less water because you can always add more, but if you add too much water, it might not work. So 1 cup there. And again, this can be a little bit messy, but kids generally love cornstarch and water because the properties are really cool. They're different than normal fluids. So we can take our cornstarch, add about a cup into a container, and then you can measure out about half a cup of water and slowly add the water and stir. So it's going to become hard to stir after a while, which is why you want to stir very slowly. And sometimes it's easier to just use your hands. And so there's different types of fluids. So as I slowly mix this, I can explain that to you. There's something called Newtonian fluids, and those are just normal fluids like water. So the viscosity or the thickness of it doesn't change when you apply a force to it. And by force, it could be anything. It could be just tipping the glass. You're applying motion and force to it, and it stays the same. It doesn't get thicker or thinner. Then there's fluids that are something called shear thinning. So they get thinner as you apply a force to them. So something like ketchup or shampoo. When the ketchup gets stuck in the bottle and you hit the back and it starts to move, it gets thinner as you apply that force to it. And so what's special about cornstarch and water is it forms a suspension, and the behaviors are very different. When you apply a force to cornstarch and water, they actually get thicker. So I'm just going to put my hands in here and try and mix this. So this was at that 2-to-1 ratio. And, okay, so it looks like it's pretty well mixed. So you can see here, the cornstarch is very liquidy. The cornstarch and water is very liquidy. It looks like a fluid, like water, when I'm not applying a lot of force to it. But when you apply a force to it, what will happen, if you have enough cornstarch in there, I just didn't mix this well enough, is it becomes thicker. So I might need to add a tiny bit more cornstarch to this one. I think I added a little bit too much water. And that's happens with science experiments. Okay, so I added a little bit more. And again, you can try using your hands to mix it, which is a little bit easier. And I'm just going to add a little bit more water here to get the right consistency, and it's just playing around with it. You want it to be like a thick pancake batter for this to work well. Okay, so I think I have it to the right consistency now, and again, this can be very messy. So it's liquidy when I'm moving it, but I can pick it up. When I apply force to it, I can pick it up, and it's like a ball, and it's hard. But then it turns into a liquid the second I stop adding that force to it. And so you can continue to play around with this. And why this happens is when we apply that force from our hands, all of the molecules of the cornstarch, which are suspended in the water, line up, and it behaves like a solid. But when we don't apply that force, it behaves like a liquid. So I can punch this and it won't splash anywhere because it's going to act like a solid. If you did that to water, it would obviously splash everywhere. And then you can play with it and try and pick it up. And again, if you squeeze it in your hand, you can put it into a ball. I don't know if this is hard to see here. It's like a solid ball, and then if you let it go, it turns back into a liquidy goo. So, are there any questions about this? I did this with my 3-year-old the other day, and she played with the cornstarch in water for a long time. And you can just continue to play with it once it's mixed well and you have the right proportions, and you can see all of the unique properties of it. Consistency, as you can see, experiments don't always work perfectly. Sometimes you have to play around with them a little bit to get the right consistency. And the reason it behaves like this is because it's forming a suspension. So the cornstarch, it's not dissolved, and what dissolved mean it is when you have, for example, sugar and you put it into your coffee or your water, all the sugar molecules disappeared. These are just suspended particles in the water. And again, they can line up or they can flow past each other, and it depends on the force that you're applying to it. So again, it looks like a liquid. It's more like a solid. If you want to keep this to play with, you can cover it and keep it for a day or two, but I wouldn't keep this for too long because eventually just the bacteria and mold that are floating around could grow in it, and so you don't want to be playing with it for too long. But a day or so, it should be fine. Please follow our page, the C2020 page, and to keep in touch with what other events we'll have coming up. So thank you.